Okay, sometimes the side that you're interested in finding is actually the hypotenuse, and so that makes our calculations a little bit more complicated. Not too much more complicated, it just puts an extra step in our calculations. So let's have a look at this triangle here. It's a right angle triangle, it has a hypotenuse which we're calling x, and we want to find out what length that is. It has an angle that's 30 degrees and it has a side length of 5 centimetres or metres or whatever it is. They don't say what units it is. So there's a few things we know about this triangle. We know that we can find accurate numbers for all the trig ratios, sine, cos and tan, because we've got the angle there. But if we want to find out what x is, we have to use a trig ratio that uses both of the sides the side that we know and the side that we're interested in. So the side that we know is the adjacent, and the side that we're interested in is the hypotenuse. So I have to choose a trig ratio that has the adjacent and the hypotenuse in it. So remembering our SOHCAHTOA, the trig ratio with the adjacent and the hypotenuse is cos, SOHCAHTOA. So let's write up what we know about this triangle. Cos of 30 degrees is equal to the adjacent, which is 5, divided by the hypotenuse, which is x. So far so good. It just looks like the questions we were doing in the last little video. But it is a bit trickier because the x in this case is on the bottom. So what are we going to do about that? I don't like having x's on the bottom. It makes life a lot more difficult. So what I'm going to do is I'm going to multiply both sides of this equation by x. I don't know what x is, but it doesn't matter. So x times cos 30 is going to be equal to x. X times cos 30 is equal to 5. Why isn't that working? 5 divided by x and then times x. I'm just going to use words. Times x. If I've got divided by x and times x, they cancel each other out. So the left hand side is still x times cos 30, but now the right hand side is just equal to 5. So we've got rid of the divided by x on the bottom there. Now what we want to do is get, at the end of this process, we want something that says x is equal to, don't we? So at the moment I've got x times cos 30 is equal to 5. So to get from x times cos 30 down to x equals, I have to get rid of this times cos 30. So again, the opposite of timesing by cos 30 is dividing by cos 30. So I need to divide both sides of this equation by cos 30. So x cos 30 divided by cos 30 is equal to 5, and I have to divide this side by cos 30 as well to make the two sides balance. So cos 30 divided by cos 30 cancels each other out, so I'm left with x is equal to 5 divided by cos 30. And I can simply pop that into my calculator down here. Let's do a bit of popping. 5 divided by and then cos 30 is equal to 5.7735. Let's just say, round it to 2 decimal places, 5.77. And there it is, we've found the length of the hypotenuse. Do you want to do another one? They are a little bit more complicated. Let's have a look. Oh, that's the one that we just did. So if this is the part that you've been asked to write down. If the unknown value of a trig ratio is in the denominator, you need to rearrange the equation. Right, let's have a look at this example. I'll just block out this solution so we can work it through together. Okay, cos 35 is equal to 2 on x. So cos 35 is equal to 2 divided by x. So first thing I need to do is to multiply both sides by x. So x cos 35 is equal to x times 2 divided by x. So dividing by x and timesing by x cancel each other out. So that leaves me with x cos 35 is equal to, what's left? Just the number 2. So let's just write the explanation out. Multiply both sides by x, and that's what I got. Now I still have a problem because I've still got x being multiplied by cos 35 and I want x by itself. So my next step is going to be to divide both sides by cos 35. So this leaves me with x on this side, and x is equal to 2 divided by cos 35 on this side. Use our calculator? Let's do it. So 2 divided by cos 35 is equal to 2.44. 2.44. And so that tells me what x is. X is equal to 2.44 units. Let's see if we've got one more example. Here we go. Find the value of x correct to 2 decimal places. Okay, well, I know this angle here, and I know the side opposite to that, and I want to find the hypotenuse. So opposite over hypotenuse is sine. SOHCAHTOA. Let's write it out whenever we... Opposite over hypotenuse. Opposite over hypotenuse, so it's sine. So I can write out a true statement. This true statement says sine of 35 degrees is equal to 5 divided by x. And I want to find x, so I'm going to multiply both sides by x. This is going to give me x sine 35 is equal to just 5, because divided by x and times x cancel each other out. I still need to get rid of that sine 35 in front of next to the x there. So I'm going to divide both sides by sine 35. My left hand side just becomes x, and my right hand side becomes 5 over sine 35. And up with the calculator. 5 divided by sine 35 is equal to 8.717233, blah-de-blah-de-blah. Let's round it to 2 decimal places and it'll just be 8.72. So x is equal to 8.72. Okay, go and do the questions in the book.